Elliptical galaxies don't really have a fame for being very spectacular objects. Today I'm going to try to convince you otherwise. Welcome back to Boring Astronomy. I'm Alessandro, your astronomer next door.
Boring Astronomy.
In case you're wondering, I'm Alessandro. I've been in astronomy for the past 20 years, and I'm here trying to share with you some of the knowledge that I've learned over the last 20 years. So the object that we're going to speak about today is M87, or Messier 87. It's the 87th object of a catalogue prepared by Charles Messier in the 17th century. I may make a full video about this catalog, but today we only focus on this specific object. This is an object I'm sure you heard about. So if you could look at the sky from Brussels, and you would look at this is around first half of the night. So you're going to find the Ursa Major, the tail of the bear points towards Arcturus, and eventually to Spica, which is the brightest star, or Virgo, the Virgin. And in Virgo is where we find our target, M87. And as you can see, it borders between Virgo, Coma, and Leo. And let's zoom on it. You see that there is a very big ellipse here. And this is the Virgo cluster of galaxies, which would deserve a full video by itself. But let's keep zooming in. This is M87. This is the galaxy. And you may argue that it's not particularly pretty. These elliptical galaxies are like this. They are basically a big bulge of evolved stars. So this means that the stars are mainly yellow, red. And this is how it looks like if you look at it through a normal telescope on the ground. Is this everything? There's more than here. There's more to this than meets the eye. Let's go to Simbad. Let's look for Messier. Active galactic nucleus. This is already something more than what we were saying before, right? There's a lot of things here. Lin, Bic, Rad, J, Gam, AGN, JIC, UV, blah. You get the point. And it has a lot of names. So for the sake of us, we'll just stick to M87. And I want to show you this because I think it's nice. I want to show you the photometry that we can get through Simbad, Messier, and all the data from our friends at the data center of Strasbourg. And you can see that there's a lot going on here, right? So remember, this is wavelength. To the left is short wavelength, which means a lot of energy. On the right, it means less energy. Let's look at this in F lambda. You can see that the peak is around red, optical but towards the red, and you can see that there's a lot going on in the ultraviolet. This is something that relates with a conversation we had with Maria Luisa Dantas. Remember, that was an interview we had last year. And there's something very interesting going on here in the radio. Stay until the end. So if we move on and we look at ESASky, we can ask ESASky for M87. And what do we have about M87 here? Let's start from optical. This is the image we have already seen, right? So this is the DSS image, the digitized sky survey. Things change if we go to something which is a bit more modern. Please don't get it personally, but this is the SDSS DR9, the 9th data release of the Sloan Digital Sky Survey. Let me zoom out a bit and let me make this comparison. So you can see the blob of stars, and you can see these other galaxies, and you can see these are galaxies. All right, so let's go back to SDSS. these are galaxies, these are the same galaxies as before. But if I zoom in, I see this small thing. This small thing is not a galaxy, it's not a galaxy which is between us and M87. Actually, if I try to look at this in X-ray, and I look at this with Chandra, I can see that this is a very collimated, high energy something. This something is a jet. This is material which is being expelled from the black hole which is at the center of M87. So we said that M87 is an AGN. This means that it has a supermassive black hole which is accreting mass, and this mass is, some mass goes inside the black hole and some mass is re-ejected in form of a jet. And you can see this in X-rays, you can see this in ultraviolet, we saw it in optical, and I assume most observatories have observed this galaxy. Plus it's at 12 degrees declination north, so it's relatively easy to observe both from the northern and southern hemisphere. The size of the galaxies is almost 10 arc-minutes times 10 arc-minutes, so it's almost the size of a decent imager for ground-based astronomy. I want to show you that we can observe this from the European Southern Observatory, from Paranal specifically. So this is the archive of the European Southern Observatory. So again, I type in image. We get again the same image as before. I just want data from La Silla Paranal. Sorry, I want the data cube. And here are the data that are available for this object. And this is actually what I was looking for. This is an hour of observation on target taken with MUSE, which is a fantastic integral field unit on VLT, and we can inspect the data. This is the target, and this is a reconstruction of the image that you can actually do. And on the right, we should get a spectrum. We don't get the spectrum. All right, let's try to visualize this. Let's see if we manage to visualize something. Right, so this is how the spectrum of just this position in the sky looks like. What you can see here is that if you only select the region of H alpha, you can actually see that there is a lot going on. There's a lot of gas and there's a lot of things going on in this galaxy, despite the fact that most of the stellar population is already aged. The last thing to remember about this object is that already 7 years ago, this object was the first black hole for which we observed the shadow projected on its surroundings. And we can get into the explanation of how that image was obtained. Long story short, there was a series of radio telescopes around the world. Took a couple of years to gather the data, process the data, and it was a fantastic technological feat, and they managed to detect and visualize how the black hole distorts the light around it and how that light arrives to us. And that was a magnificent feat. As I said, I bet you knew something about this galaxy. I hope you like this galaxy, and I hope you will like looking at it one way or another in the sky of April. And obviously, if you like this video, like, subscribe, and stay bold. Ciao.